Welcome back. This is the third lesson about tree traversal, and it's the very last lesson about trees. So in this lesson, we'll look at creating procedures or methods that will let us traverse a tree. So in this lesson, we'll revisit the code that let us create a tree using object-oriented programming. If you haven't done this, you might like to go to those previous lessons and have a go at that before attempting this lesson. But once you've got the OOP program written, we're going to add a method for breadth first traversal and a method for depth first traversal. So if we create a tree using object-oriented programming, we have to create two classes. The node class, a tree node has got some data and left and right pointers, and we create a tree, and a tree is actually a very simple data structure. It's just got a root node, and then we'll build up the other nodes by appending them. I'm not going to show you the append method now. If you want to write this program, go back to the previous programming lesson. All right, so let's assume that you've got the OOP tree program all written. Now we're going to add a method for breadth first traversal. Let's remind ourselves what that involves. Create a print queue, add the root node, loop while the queue has any nodes in it, dequeue the front node, print the data, and enqueue its children. So those are the lines that we need to add to our program. Let's write them out in order. Create a queue, add the root node, while the queue is not empty, dequeue the front node, print the data, enqueue the left and right nodes. So do you want to try and write that program for yourself? I'm going to go through it line by line. But if you want to stop the video and have a go at that now, this would be a good time. Otherwise, on to the next slide. So I'm creating a method. I'm calling it breadth because it does breadth first traversal. I'm creating a print queue which only contains the root node. Now, while the queue is not empty, so while the length of the queue is greater than 0, I dequeue, print, and enqueue. Remember those lines. We dequeue the front of the queue, we print its data, and we add its left and right nodes, like this. Dequeue the front item, so pop item 0 from the queue, store it as a node, and print the data from that node. And now we're going to append the left and right pointers. So if the node has got a left pointer, append the left node to the queue, and if it's got a right pointer, append the right node to the queue. So you can see what's happening. We're taking one node out of the queue and we're appending two new nodes to the queue. Eventually we'll get to a situation where there are no left and right nodes, and then we stop appending and the queue starts to get smaller. That's it. That's the entire method. So let's go quickly through it. We create a queue with the root in it. We keep going round and round, looping as long as the queue's got any items in it. And every time round the loop, we pop the front of the queue, we print its data, and we add the left and right nodes to the queue. Here's the main program. We enter a root value, and then we loop adding more values to the tree using the append method, which we wrote in the previous presentation. And then the last line of the program is to use the breadth method to print out all the nodes in the tree. And you should find that it prints them out in the right order of breadth first traversal. So now you try it. You can follow these instructions step by step or try and write the method from memory. If you want an extra challenge, you can add a breadth first procedure to the 2D array program using the same methods. It's a little bit harder. OOP is quite convenient. Using the 2D array is a bit harder. So if whatever method you use, you've ended up writing this complete program, including the breadth first traversal method, try running your program, add these values 7, 2, 9, 1, 5 and 14, and then your program should finish. After you've added that data, press enter and it should print out the values in the correct order, 7, 2, 9, 1, 5, 14. If it does that, your program's working. Well done. So depth first traversal, that's with the triangles and the recursive structure. It's actually really quite an easy program to write. So let's have a go now. Let's just remind you what happens. We create a print stack, we push nodes to the stack. The base case is when we've cleared the pointers, and when we reach a base case, we pop from the stack and print the data. Now, we can actually do that in fewer lines. What we do is we create a traverse method which is recursive, and we traverse the left node, we traverse the right node, and then we finally print the data at the root node. So it's a very short method. We create the traverse method in the node class, not in the tree class, because it works node by node, treating each node as the root of a new little tree. So go to the node class and start creating a new method. I've called it traverse. It does a post order depth first traversal, but I don't want to call my method anything as long as that. I'm just calling it traverse. If the node has got a left pointer, traverse the left node. If it's got a right pointer, traverse the right node. So you can see that this is recursive. If the left pointer exists, recursively call the traverse procedure again. Then, if the right pointer exists, recursively call the traverse method again. And then finally, print the data of the root node. And that's it. That is it. It's a very, very short and simple method to write. It's recursive. To traverse a node, we traverse its left pointer, then we traverse its right pointer, and then we print its data out. In the main program, we call it from the root value. So remember, it's a node method, so we call it from the root node. Look at that final line of the program, mytree.root.traverse. So traverse from the root, but because it's a recursive program, it will continue to dig down until it reaches the bottom of the tree and then start to print out the values. Well, you can simply follow that program that I've just shown you and make it work that way, or try and write it from memory. As an extension task, you could add a depth first procedure to the 2D array program. That's a bit more challenging, but if you're up for a challenge, you want a more difficult programming task, then that's quite a good one to test your ability. And once you've written your program with your depth first traversal, try entering those values, and if your program is working properly, it will print out the values in this order: 1, 5, 2, 14, 9, 7. So if it's working, congratulations. Even if you haven't got it working, as long as you've got the general idea of how a depth first traversal works, you're doing fine. So well done. That's it for trees and binary search trees and tree traversals and the whole lot of it all done. So congratulations and pat on the back.